yes, trigonometry. So one of the first things you need to be able to do is convert from radians to degrees and degrees to radians. So this was all taught earlier. This is just a quick review. 180 over pi is equal to 1, so that means we can multiply radians by 180 over pi, because we want the pi to cross out, and it'll convert it to degrees for us. And we can multiply degrees by pi over 180, since it's just equivalent to 1, and it'll give us radians for us. So we have the axes, and the coordinate plane is going to be very important for this chapter. So you need to know which quadrants are which I've already labeled on your unit circle or on your set of axes. And it's important to know that they're labeled this way because that's the way the screamer, right, in your book, the roller coaster, the unit circle goes. The unit circle goes counterclockwise as we're going around the circle. So we have to get used to where each quadrant is. So if the unit circle goes counterclockwise, if you just get on the unit circle and you haven't moved at all, you've gone 0 degrees. So this spot on the unit circle is 0 degrees. We all know a whole circle is 360 degrees, right? So if I go all the way around and I land back in the same spot, that also could be 360 degrees. So it depends on if you've moved or not. If you go a quarter circle and you end up here, that's 90 degrees. Half a circle is 180 degrees. 3/4 of a circle is 270 degrees. I didn't leave myself much space down there. So you want to know these important degree marks around the unit circle so that you can answer questions like number 1, what quadrant is 95 degrees located in? So you're going to go 95 degrees. So from 0 counterclockwise, because it's positive, 95, a little bit more, would land me in quadrant 2. And expect to see multiple choice with Roman numerals on the test. So, to sum it up, if you're between 0 and 90, you're in quadrant 1. If you're between 90 and 180, you're in quadrant 2, etc. And between 270 and 360, you're in quadrant 4. But you might need to convert it to degrees first in order to answer these questions. And if it ever comes out to be more than 360 degrees, just subtract 360 degrees until you get a number between 0 and 360. So here we go, converting 205 degrees. So degrees, you've been dealing with degrees for a long time now. You know they do not have a pi symbol, right? 205 degrees is how it's written. Radians always have a pi symbol. It's always an improper fraction with a pi on top. So if I need to convert this to something with a pi on top, I need to use the fraction that has pi on top. Now, don't just start multiplying things out here. You want to reduce. So I see that 205 ends in a 5 and 180 ends in a 0. So I know 5 divides into both of these numbers. So I'm just going to divide by 5. And maybe you don't know what 205 is divided by 5. So divide by 5. 5 goes into 24 times. That gives me 20. So I'm left with 5. So apparently it goes in 41 times. Maybe I don't know what 180 divided by 5 is. 5 goes into 18 3 times. 15 subtract leaves me 30. That goes in 6 times. It goes in 36 times. I'm left with 41 and 36. I don't think anything goes into that, but you could try dividing by 2. 41 doesn't divide by 2, right? You could try dividing by 3, see if anything goes in. And if not, 41 pi over 36 is the answer. It needs to be reduced and improper. And there is a pi button in Schoology, and it's lowercase pi. It's not that huge looking thing. I don't remember what Greek letter that is. Okay, so number 2, 7 pi over 9, we want to convert this to radians. Nope, how about from radians to degrees? So you know degrees do not have a pi in the answer. So I want to multiply by the fraction that has pi on the bottom, so 180 over pi, so that the first thing I can do is cross out those pi's. Now I know I'm going to have radians. So don't multiply 7 times 180, that's bigger than necessary, right? 9 divides into 180, right? And again, maybe you guys need to do this. 9 goes into 18 twice, 0, so 20. Now all the numbers at the bottom have been crossed out, and any number you have left, you just multiply those together. 7 times 20 is 140 degrees. So if you haven't yet, pause the video and try number 3 and number 4. The only thing a negative is going to do is give you a negative for the answer. Don't forget that negative on your test, though, because we have to mark it wrong if you give us a positive answer. So it's converting to radians, so I need a pi on top. First thing I notice is that they're both even. So how about they both end in 0? So I can divide this by 10. I'm just leaving that negative sign there. Divide this by 10. Then all the denominators, nope, not what I wanted to say. 13 and 18 don't have any common factors. 13's not even. 3 doesn't, nothing goes into 13, right? So you take everything that's left, including your negative sign, 13 and pi on top, and everything that's left on the bottom. Negative 13 pi over 18 radians is equivalent to negative 130 degrees. Okay, last example. Pause the video and try it on your own. We are going to convert negative 7 pi over 10 from radians to degrees. So I need that pi to cross out, so I need a pi on the bottom. So I'm using 180 over pi. The pi's cross out right away. 10 goes into 180 18 times, and now I'm left with negative 7 times 18. Maybe I need to do this. 7 times 18, or 7 times 8, 56, carry the 5. 7 times 1 is 7, plus 5 is 12, 126. It was negative 126 degrees. So negative 7 pi over 10 radians would land at the same spot as negative 126 degrees. Let's see what's next. Okay, find the reference angle. The reference angle is always between the terminal ray, which is your hypotenuse, and the x-axis. Always make sure you're connecting to the x-axis. Never draw a line to the y-axis. If you love formulas, there's formulas depending on which quadrant you're in, and we'll talk about them as we go through the examples. So find the reference angle for 205 degrees. So I would start by drawing myself a tiny set of axes. We're working on memorizing those important degrees as you go around. 0, 90, 180, 270, all the way back around is 360. So 205 degrees, it's positive, so it's counterclockwise. Starts where the unit circle starts. What happened to my 0 and my 360? Starts where the unit circle is supposed to start, goes counterclockwise, bigger than 90, bigger than 180, but just a little. So this approximately is where 205 degrees would be. Then I connect it with the x-axis to make a right triangle, and the angle is in here between the x-axis and our hypotenuse. So this is why when you're in quadrant 3, you can see the formula on the side. It's theta minus 180. Remember, the number we give you is theta. So maybe I should write them that way. Theta equals 205. The number we give you is theta. So for this one, we're going to do 205, because that's the big green arc, minus 180, because 180 would be from here around to there. And I hope you can see that the orange plus the red makes the green. So if I do 205 minus 180, it'll give me my reference angle. So my reference angle is 25 degrees. Try number 2. So we've got our axes, and if you don't need to label your axes or draw your axes at all, that's great. This video is more intended for the people who do need the extra help. So 0, 90, 180, 270, back around is 360. So this angle, 310, positive, so counterclockwise, more than 270, so I know I land in quadrant 4. I make it a triangle with the x-axis, and my reference angle is right here. So hopefully you can see that the red plus the green makes 360. That's why for this one we do 360 minus 310, and it gives us 50 degrees for our reference angle. Pause the video and try number 3. So 270 degrees, it's positive, so it's counterclockwise, not quite to 180. Did I say 270? It's 170, right? Okay, so connect it with the x-axis. The angle we're looking for is right here. Hopefully you can see that those two angles make 180, which is why in quadrant 2, 180 minus theta gives you your reference angle, 10 degrees. Okay, let's see what's next. Same reference angle. So every quadrant has one reference angle that's between 0 and 90 degrees, which means the same reference angle appears in every quadrant. You've seen this in your book and in some quizzes and stuff written this way. Find all the locations that would have to climb the same vertical distance to exit the screamer as if the screamer got stuck at 160 degrees. So here's what we do. There's formulas on the side if you love formulas, but the picture helps me the best. So draw what's happening for the screamer right now. Put our labels that we know. Right now, the screamer has gone 160 degrees, so not quite to 180. Here's the screamer right now. Remember, that's a point on a circle, but we just don't draw the point on, we don't draw the circle very often. So that was 160. So I can find the reference angle by connecting it to the x-axis and finding this angle here, which 180 minus 160 will give me a 20 degree reference angle. That's one of the answers. In quadrant 1, 20 degrees would have to climb the same distance to get off the screamer. I'll show you what that would look like. That would be if it went to here, right? If I could draw this well. This would be the same vertical distance, because it's 20 degrees, to get off the screamer. So that's quadrant 1 and quadrant 2. Remember, 160 is one of the 4 answers. Then, in quadrant 3, there would be a matching triangle. Just kind of reflect that triangle over the x-axis, this 20 degree angle, whatever that whole thing. So let's do that one. From the beginning, past 160, past 180, this far, that would be a location on the circle that would have to climb the same distance to get off. So 180 plus 20 gives me 200 degrees. 200 degrees. That's the third spot on the circle that has to climb the same distance. And then the last one would be in quadrant 4. You can draw your matching triangle. This has to be 20 degrees. We want to know counterclockwise all the way past all of this stuff to get to here is how far? Well, it's 20 degrees from 360. So 360 minus 20, 340 degrees is my fourth answer. So see if you can pause the video and try number 2. So the first thing you need is the reference angle. So work on finding the reference angle for 230. So 230 past 180, but definitely in quadrant 3. Make a triangle with the x-axis. Remember, the gray is 230. So 230 minus 180 will give me this reference angle. What is that, 50 degrees? 50 degrees, which is in quadrant 1. If I could draw a straight line. At 50 degrees, you'd have to climb the same vertical distance. Now we need to put that triangle in all the other quadrants. So try to draw a 50 degree triangle in quadrant 2. This would be 50. So just from where the circle starts around to that would be 180 minus 50. 130 degrees. I should leave my answer somewhere. So 50 degrees, 130 degrees. Remember, 230 was already an answer. And then in the last quadrant, a right triangle, that's 50 degrees. I want to go around from where the roller coaster starts all the way that far, which is 50 degrees away from 360, so 310 degrees. These would have the same height to climb if the screamer got stuck, or they have the same reference angle, however the question is worded. Okay, let's see what's next. Find the reference angle on the three other locations that have the same reference angle. So just worded differently. I'm going to post the answers to this. So pause your video now. It's the same question, just worded differently. Pause your video and see if you can answer these. Don't unpause it until you finish number 1 or you're ready to see number 1 completely completed. Okay, so first I started by finding the reference angle for 100. That landed me in quadrant 2 and it had a reference angle of 80. So quadrant 1, 80 degrees would have the same reference angle. Then in quadrant 3, 80 degrees more than 180 landed me at 260 degrees. And then in quadrant 4, 80 degrees less than 360 landed me at 280 degrees. Try number 2. I'm going to post all the answers when you unpause the video. Pause it. Okay, again, find the reference angle first. 355 put me all the way in quadrant 4. It was a 5-degree reference angle. So quadrant 1, 5 degrees, would have to climb the same height. Quadrant 2, 180 minus 5, so 175 degrees would have to climb the same height. And quadrant 3, 180 plus 5, so 185 degrees would have to climb the same height, or, worded differently, have the same reference angle. Okay, let's see what's next. Okay, trig on the unit circle. These are very important. And again, this was all taught to you already. This is just a review. I'm not going to draw the circle. On the unit circle, the x value is equivalent to the cosine of theta, and the y value is equivalent to the sine of theta. And then tangent, because tangent is opposite over adjacent, tangent is equal to the y value divided by the x value. So we're going to use that to help us evaluate these things. If you know how to use the unit circle, great. You should have one, be able to draw one on test day. But if not, we can do it without the circle. So here we go. Sine of 225 degrees. 225, I'm going to leave some space because I know what quadrant it's in. 225 degrees is going to take me into quadrant 3. I'm going to make a triangle with the x-axis. Remember, this is a point on the unit circle. We just don't draw the circle because it takes up space and it's not necessary. But that means the hypotenuse is 1. So work on finding your reference angle. I feel like we've been doing that a lot right now. So you're in quadrant 3. This one's 180. I didn't label it, right? 0, 90. This is 180, 270. So find the reference angle. Hopefully you get 45 degrees. Then those are our special triangles. Maybe we should draw our special triangles up the top. We have 45, 45, 90 triangles with the hypotenuse of 1. Both sides are root 2 over 2. And then we have 30, 60, 90 right triangles with a hypotenuse of 1. The short leg, which is opposite the small angle, opposite the 30, is 1/2, and the other leg is root 3 over 2. Those will be the only numbers that ever show up in my triangles. So, 45 degrees, they're both root 2 over 2. But we are trying to find the coordinates of that blue point. I like to make it red. So, pretending this is on a circle, right? And this is our xy axes, that big red point has a coordinate to it. And our triangle helps us find those measurements. It's left root 2 over 2, so that's negative. Remember, the triangle measurements are positive, but left is negative on the plane. And it's down root 2 over 2, so that's also negative root 2 over 2. Now that I have it all labeled, this question wanted sine. Sine is the y value, so the answer is negative root 2 over 2. See if you can set up number 2. Close my parenthesis. 150 degrees. .150 degrees puts you in quadrant 2. makes a right triangle with the x-axis, hypotenuse 1. Here's the big red dot that I'm trying to find. Find your reference angle in quadrant 2, so 180 minus 150 gives me 30 degrees at 0, 0 at the reference angle. Naturally, you could fill in the 60 degrees in the other spot because it's a 30, 60, 90 right triangle, hypotenuse of 1. Label the missing sides correctly. So the short leg opposite of 30 is 1/2. The other leg is root 3 over 2. Then label the coordinates of the point. The x is left root 3 over 2, so negative root 3 over 2. And the y is up 1/2, so positive 1/2. Then look at the question. The question said find cosine. Cosine is x, so the answer is negative root 3 over 2. See how much of these you can do. Pause the video if you don't want to see me go over it so you can practice on your own. Otherwise, here we go. First thing you need to do, if you're not memorizing the unit circle, is turn 7 pi over 4 into degrees. So the pi's cross out, 4 goes into 180 45 times. You're going to learn that pretty quick. And maybe you need to do this. That's 35, carry the 3, 28, 29, 30, 31. 315 degrees. This is the same as, not sine, cosine of 315 degrees. But we made you do an extra step, right? I gave it to you in radians, so you had to do an extra step. Now graph it. I know where 315 is. All the way around to here, 315. Make a right triangle with the x-axis. The hypotenuse is 1. 360 minus 315 gives you 45 degrees for your reference angle. This is why we practice reference angle. I'm not going to show that work every single time. 45, 45, 90. Both sides are root 2 over 2. But the point might have some negatives. So look at where it is on your xy axis. Right root 2 over 2 is positive, but down root 2 over 2 is negative. And this question said cosine, so the answer is the x value. Cosine comes before sine in the alphabet, x comes before y in the alphabet. Root 2 over 2 is the answer. Try number 4. 330 degrees. Triangle with the x-axis. That would leave 30 degrees for the reference angle. Hypotenuse is 1. Label your missing sides. See if you can find the coordinate. Small side opposite 30, 1/2. The other one's root 3 over 2. Right is positive. Down is negative. This question wanted sine, which is the y value. The answer is negative 1/2. This is kind of the reason we taught you everything we've taught up to this point, is to be able to do these little tiny questions. Okay, tangent now. Remember, tangent was y over x, but we start out the same way. We got to find the coordinates. So if you don't know where pi over 3 is, start by converting it to degrees. 6 goes into 180 60 times. This is the same as tangent 60. We could ask it in radians. We can ask it in degrees. 60 degrees. We'll have a reference angle of 60 degrees because it just lands in quadrant 1. Hypotenuse is 1. Label the missing sides and come up with your coordinate. Opposite the 30 is 1/2. Root 3 over 2. It is right 1/2, so that's positive, and it's up root 3 over 2, so that's also positive. But now we have to do math. Tangent always requires extra math. Tangent is y over x. So we need to take our y value and divide it by our x value. Y over x. In no way is that an appropriate answer. You never answer fractions and fractions. That's just my work. To get that fixed, you keep the top and you flip and multiply by the bottom. Keep the top, flip and multiply by the bottom. 2 on top, 2 on bottom, cross out. The answer is root 3. There's no square root in the denominator, so that is the answer. 3 pi over 4, convert it to degrees. Pi's cross out, 4 goes into 180 45 times. Maybe you have to do this. 15, carry the 1, 12, 13, 135 degrees. Set up your axes, draw your picture. See if you can find the red point. I'm going to pause it, and I'm going to have the coordinates of the red point when I'm done. So get that far. Okay, so it's left root 2 over 2, so negative root 2 over 2, comma up, so positive root 2 over 2. To find tangent, it's y over x. But notice your y and the x are almost identical, except one of them is negative, so this fraction just comes out to be negative 1. The answer is negative 1. Okay, these ones are special because they don't make triangles, so don't just jump into drawing a triangle right away. Convert them all to degrees. Let's take a second and convert all of these to degrees. I'm going to pause the video, and all of these are going to be written as degrees when you unpause it. Okay, check yours with mine. I'm just going to draw one set of axes because all of these are special. So cosine of 360. Let's label our axes like we've been doing, right? 0, 90, 180, 270. Back around is 360. So cosine of 360 wants to know the x value right there. Remember, it's on a circle. We don't draw the circle, but that's right 1 up 0. So that's the point 1, 0. So cosine is x, because c comes before s in the alphabet, x comes before y in the alphabet. Cosine of 2 pi, or cosine of 360, is 1. Number 8, sine of pi over 2. Sine of 90 degrees when you convert it. Remember, 90 degrees is up here, and that's a point on a circle. Maybe I should draw the circle, right? It's a point on a circle with a radius of 1. So on that, I've gone left, right, 0, but up 1. Sine is y. So the y value, coincidentally, is 1. The answer is 1. Tangent of 180. Tangent of pi is the same as tangent of 180. So 180 is over here. The coordinate over there is left 1, so negative 1, comma 0. Tangent is y over x. The y over x. The y value is 0. The x value is negative 1. 0 divided by anything is 0. Last one, 270 down here. This point is 0, comma negative 1. Tangent is y over x. That's negative 1 over 0. Anything divided by 0 is undefined. The answer to number 9 is undefined. Okay, lastly, graphing sine, and then we'll do graphing cosine. So, the equation for sine is written. The parent graph for sine is there. Remember, the amplitude is always positive. That's what these absolute value bars mean. The amplitude is always positive. It's a distance or a length, which is always positive. If it's negative, it means there is a vertical reflection. The period is 2 pi divided by whatever b is. The phase shift is always left, right, h. Remember, it's opposite what it looks like because you do zero product property. The vertical shift is up, down, k. The first point you begin on is h, and it's on the midline. Let's draw our midline in. Our midline, I'm going to use kind of a thick pen here because I need you to see it. Our midline is where these 3 points land, right on that midline. And then the beginning point is right on that midline. The end point is right on that midline. It's the period away, h plus period. And then the middle is going to be right on the midline as well for sine. And then the first point does A and the second point does opposite A. So here we go. Let's write some answer blanks. Copy down this question. Okay, these are all the things I need to know in order to be able to sketch this graph. So the amplitude is A, but it's always positive. In this case, A is positive 3. But don't forget, if you tell me negative 3 ever, or negative anything, it will be marked wrong. The period is 2 pi divided by B. There's an imaginary 1 in front of this x, so divided by 1, which is just 2 pi. The phase in the parentheses, it says minus pi over 4. So if you do opposite, you're going to go right pi over 4. I wrote an arrow. You would type out the word right pi over 4. It always has a direction. Vertical shift is down. I'm going to start using words. Down 2. That is how you would type it on the test. A is positive, so there is no vertical reflection. So I would begin at right pi over 4. So pi over 4, right? Right is positive. And I would end at pi over 4 plus the period. So pi over 4, this is over 1, so times 4, plus 8 pi over 4. I'm going to end at 9 pi over 4. So set up some axes. It's all positive, so I don't need a lot of space. Down to probably right here. And then set up our axes based on our beginning and end. They're both over 4, so we'll go pi over 4. That's 1/4, 2/4, 3/4, 4, 5, 6, 7, 8. This would be 9 pi over 4. Count by ones because it's easiest. Midline. Our midline, our vertical shift is down 2. So I'm going to draw, it's imaginary, that's why I'm making it dotted. If you graph this on Desmos, there's not going to be a green line right there. Midline at down 2. And then my beginning point is at pi over 4. For sine, it's on the midline. My end point is 9 pi over 4. For sine, it's on the midline. Then find the middle. 1 plus 9 is 10 divided by 2. 5 pi over 4 would be the middle. 1, 2, 3, 4, 5 pi over 4 on the midline. Sine has 3 points on the midline, beginning, middle, and end. Then find the middle of the left half and instantly do A. A is positive 3, so up 3. Find the middle of the right half and instantly do opposite A, down 3. Try to draw it to look like a sine curve. It's a wave function, and it does repeat over and over and over again, but we just graph one cycle. Okay, here we go. Number 2, copy it all down, set up all your answer blanks. Okay, there's all my answer blanks. Pause the video, I'm going to start going. So, amplitude. I know A is negative a half. The negative makes me circle yes. The amplitude is still just 1/2. It's a height of a hill. Heights do not have negatives. Period. 2 pi divided by, there's an imaginary 1 there again. So 2 pi. Phase, it says plus pi. That's actually going to move it left pi. There is a pi button in Schoology, but if you do spell it out, it's spelled like this. Just P-I. It's not the type of pie you eat. So if you're going to spell it out, try to spell it correctly. Then vertical shift up 2 because of the plus 2. So it's going to begin left pi. Left as a number on the number line is negative pi. And it's going to end that beginning plus the answer to period, which is going to be positive pi. So set up some axes. I need them in the middle this time because I go left and right. I'm counting by pies, so I don't want to actually count by pies because that's going to be too close together. So I'm going to go 1, 2, 3, 4 and call that negative pi. 1, 2, 3, 4 and call that positive pi. Every tick is 1 for my y-axis. And I start with my midline. Where to go? Up 2. Remember, this is imaginary just to help me get the graph. That's as if that's my new x-axis. Now, my beginning point is at negative pi on the green line. Sine is on the beginning point of sine is on the green line. My end point is at pi on the green line. My middle point, which I can see pretty easily, is on the green line. My left section instantly does A, actual A, which is negative a half. That's why this has a vertical reflection. So I'm going to go down half a unit. My right side does opposite, so up half a unit. And try to make it look like a sine curve. So this is compressed vertically because it's 1/2. Okay, last sine example. Copy down all the answer blanks. I'll sketch mine in. Okay, there's all the answer blanks. Okay, right away. See how this is 2x? That means this is not in graphing form yet, and it means the period's not going to be 2 pi for a change. So you want to change it to be y equals -2 sine. You're going to factor that 2 out front, GCF factoring. When I divide by 2, I'll just get x, and I'm factoring out, that means divide. So -pi/2, you're dividing out the 2. Understand that if you redistributed this, that would be 2x, and that would be pi, like we needed. And then the +1 stays the same. Now we can start answering our questions. Amplitude is always a positive number. I'm going to say it over and over again, and you're going to choose negative on accident one day on the test. Amplitude is +2, but since it's negative, it has a vertical reflection. Period is 2 pi over b. Now we finally have a b that's not 1, so divide by 2. This time the period's pi. This is compressed horizontally. Then it says it says x minus pi over 2, but that actually moves it right pi over 2. And then it says +1, that actually moves it up 1. So my beginning is right pi over 2, which is pi over 2. And my end is that answer plus the answer to period, which this time is pi. So this is pi over 2 plus over 1 times 2 times 2. 2 pi over 2, which is 3 pi over 2 is where this is going to end. So set up some axes. It's counting by 2s. So I only have 3 of them, right? So I'm going to leave a little bit more of a gap. So 2 tick marks, call that pi over 2. 2 more tick marks, call that 2 pi over 2. 2 more tick marks, call that 3 pi over 2. I always have my y-axis count by 1s. So midline, up 1. So my imaginary x-axis is now up 1. I'm graphing sine with a beginning at pi over 2, so that's on the midline. An end at 3 pi over 2, so that's on the midline. A middle, I can easily see the middle at 2 pi over 2 on the midline. And then on the left half of that, you instantly do A. Actual A is down 2. And on the right half of that, you do opposite A, so up 2. So here is my sine curve for number 3. Now we're going to move on to cosine. Basically the same equation, but cosine in there instead. All the A, B, H, and K do the same thing as they did for sine, so I didn't write that down. But the beginning and end change. Look at my graph. The beginning is instantly A above the midline, or below, and the end is A above or below also. Notice that your beginning and your end line up. This is the beginning, and it has the same height as my end. Then the end is found the same way, H plus the period. The middle is opposite A. Maybe we should add that. So if you went up 2 for the beginning and end, you'll go down 2 from the midline for the middle. And then the middle of those sections are actually on the midline. Let's add our midline to this graph. I'm going to make it extra thick just so you can see it. The midline's right here. And there's only 2 points on the midline this time. So let's jump right in. Okay, there it is with all the answer blanks. See how many of these you can fill in. The answer blanks don't change, which is nice for sine or cosine. It's when we start graphing it that things are going to change. So amplitude is 1/2. This is compressed vertically. Period is 2 pi over the imaginary 1, 2 pi. Phase is right pi over 3. And vertical is up 2. There's no negative sign, so there's no vertical reflection. That means it's going to begin right pi over 3, which is positive pi over 3. And it's going to end at pi over 3 plus the period, which is over 1 times 3 times 3. Pi over 3 plus 6 pi over 3. It's going to end at 7 pi over 3. So axes. counting by threes because my beginning and end all have denominators of 3. So the first one's pi over 3. Then I'm just going to count 2, 3, 4, 5, 6, 7 pi over 3 is as far as I need to go. My y-axis, I always count by ones. Just look at the axes, right? If it's multiple choice, look at what's graphed. And my midline is up 2. So the whole beginning is exactly the same. But now if you graph sine instead of cosine, it's all going to be wrong. So our beginning point is pi over 3, but for cosine, you instantly do a. In this case, a is 1/2. So from the green line at pi over 3, I'm going to go up half a unit. My end is 7 pi over 3, and it's supposed to match up half a unit. Find the middle, opposite, down half a unit. Then find the middle of those 2 points. This time it's not a perfect coordinate, so it's going to be approximately there. Find the middle of those 2 points on the green line is what I was supposed to say. And then try to make it look curved like a cosine. Remember, it repeats on and on, right? This is not going to be correct, but in general, it keeps doing the same thing, but spaced out better than I can do it by hand. But we just graphed one period. Okay. Number 2. Okay, I see -3, but I would never write negative in an amplitude answer blank. 3 for the amplitude, yes for reflect vertically. Period, 2 pi divided by that imaginary 1. Phase, it says plus, which actually goes left, pi over 4. And vertical actually matches up 1. Begin left is negative pi over 4. End, that number, plus the period, times 4, pi over 4 plus 8 pi over 4, it's going to end, at 7 pi over 4. Set up your axes. My beginning and end are counting by 4s, so negative pi over 4. Make sure you can see your negatives. 1, 2, 3, 4, 5, 6. This would be 7 pi over 4. Count by ones. Midline at up 1. Now we pause and we remember that we are graphing cosine. The beginning point is supposed to instantly do a from the green line. Remember, a is -3. So down 3 from the green line at negative pi over 4. Your end, 7 pi over 4, is supposed to match down 3. The middle of that is supposed to be 3 above the green line. And then the middle of those pieces on the green line, on the green line. When you just plot the 5 points for cosine, it's very much going to look like a pointy V, but try to make it look like a curvy wave function. There's my cosine graph. One more. Notice right away, it is not 1x, right? It's 1/3 x, so we have to do some math to get it in graphing form. So graphing form, cosine, bracket, we're going to factor out the 1/3. Remember, I'm dividing by 1/3, so that's going to give me x. When you divide pi by 1/3, you actually get 3 pi. Take a look and make sure you understand. What's 1/3 times 3? Well, that's going to give me pi, like I'm supposed to get. So it's actually 3 pi in graphing form. Amplitude. There's nothing there. What's the amplitude? If there's nothing there, there's an imaginary 1 in front, so the amplitude is 1. It's positive, so there's no reflection. The period is 2 pi divided by 1/3. Remember, you keep the top and you flip and multiply by the bottom. So the period's actually 6 pi. Phase is going to be left 3 pi. Vertical is down 1. The beginning, left 3 pi is -3 pi. And the end is the beginning plus the period, which we got 6 pi for that. So it's going to end at 3 pi. So set up some axes. This time I'm going from negative 3 pi to positive 3 pi, so I'm going to go 2 tick marks and call it a pi. Negative pi, negative 2 pi, negative 3 pi. Just make sure your tick marks are the same distance apart. My y-axis is counting by ones, and my midline is down 1. Then my beginning point is at negative 3 pi, but you instantly do the amplitude, which is positive 1, up 1. My end point, 3 pi, up 1. My middle, which is easy to see, opposite, down 1. The middle of those, which don't land on whole numbers, will be on the green line. Try to make it look like a curvy wave cosine function. And that's it. So hopefully this helps you prepare for your essential skill on trigonometry. Hope you're doing well.